Hello everyone, I hope everybody is fine. This is a lecture on quadratic relations and the transformations involved, basically putting everything together. Um, we want to talk about transformations of quadratic relations. And on this huge chart, which I hope you will be uh, copying it very patiently and meticulously later on, we start with y equals a times x minus h squared plus k, which is the general form of a quadratic relation. It's called the vertex form. Now, the role of a we investigated before. I'm just reviewing what we have done so far. The value of a, the number in front of the whole equation, is either greater than 1, or it's less than 1 but still positive, or it's negative. So three cases here I have divided. If the value of a is greater than 1, such as 2, 3, 4, then we do have a vertical stretch or expansion by a factor of a. If the value of a is less than 1, such as 1/2, 1/3, 0.1, and so on and so forth, the type of transformation, the name of the transformation is called vertical shrink or compression by a factor of a, which could be 1/2 or 1/3, as I said. And if the value of a is less than 0, which means that there's a negative sign in front of the whole equation, then we do have a reflection in the x-axis, which means that the parabola opens down, as I wrote in this box. In the other two cases, the parabola opens up. So whenever the value of a is positive, parabola opens up. And whenever the value of a is negative, the parabola opens down. So this takes care of changes that the value of a could possibly have. We go and talk about h. We saw it in the lecture earlier. If the value of h is positive, let's say we have x minus a positive value, let's say x minus 5, for example, then we have a horizontal shift or translation to the right by, of course, 5 units. So here I may add to the right by actually h units, okay? Now, depending on what value of h is. But if the value of h is negative and we have x minus a negative value, such as x minus -4, which would be x plus 4 actually, then in that case we have a horizontal shift or translation to the left by 4 units. So x plus 4 all squared, horizontal shift to the left by 4 units. X minus 5 all squared, horizontal shift to the right by 5 units. Same thing here, to the left by h units, whatever that h value is. So that's the second transformation. The third one is the value of k that could possibly change. K could be positive or negative. You can have y equals, let's say, x squared plus 5 or like x squared minus 5, something like that. If k is greater than 0, we have a vertical shift or translation up by k units. Again, up by k units. Or if the value of k is negative, it's a vertical shift down by k units. Now that k could be 5, could be 4, whatever it could be. So these are the transformations that are involved in quadratic relations. The vertex of the parabolas in general is located at h comma k. And h is found from here, from the equation, and k is right there. Equation of axis of symmetry, which is that vertical line cutting the parabola in half, is x equals h. So whatever the x coordinate of the vertex is, x equals that number will be the equation of the vertical line known as axis of symmetry, which makes sense because it passes through the vertex of the parabola clearly. And then optimal value is always equal to k, which is the y coordinate of the vertex, of course. Optimal value is the same as maximum value or minimum value. Depending on the parabola opening up or down, we're going to have a minimum or maximum point respectively. And as a result, we're going to have max value or mean value. But it's always equal to k no matter what. Now here are a few examples. We have a quadratic relation here, y equals 2 times x minus 1 squared plus 8. And we want to find out the vertex. So we know the formulas in the box over there. I hope you did copy that. The vertex is always h comma k. So in this case, what is the value of h? You are right, it is 1. What is the value of k? Of course, it is 8. So the vertex is at 1 comma 8. That's the vertex of this parabola if you want to graph it later on. the equation of axis of symmetry is always x equals to the x coordinate of the vertex, which is 1 in this case. So I'm going to go x equals 1. Direction of opening clearly is upwards because the value of a is positive. See here, earlier we said that the problem opens up if a is positive. So I'm going to write down here direction of opening. Optimal value is, of course, 8. And in this case, because it opens up, we have a minimum point, so it's actually a minimum value. So I'm going to write down here actually a minimum value, and that's equal to the y-coordinate of the vertex, which is clearly 8. Can you imagine how many test questions can be designed using these properties? So y equals 6x squared minus 3 is the next one. The vertex is located at 0, negative 3, because h is 0, so x equals 0. In other words, that is the equation of the y-axis, which plays the role of the axis of symmetry. Then direction of opening is again up, because a is positive clearly. And we have a minimum value of negative 3 this time. So minimum value equals negative 3. Next exercise here, we have a negative 1 for the a value. The h is negative 4, so x minus negative 4 becomes x plus 4, and the k is 5. So we go negative 4, comma 5 is the equation of the vertex. Equation of axis symmetry, x equals negative 1, because that's what h is. Direction of opening this time is going to be down because the value of a is negative. And finally, optimal value is 5, but that is actually a maximum value this time because the value of a was negative. The last question here, we have negative 1/2. So direction of opening is going to be down again, I bet, because a is negative. Equation of axis symmetry will be x equals, this one I think, this one I wrote it wrong. It's x equals negative 4. X equals negative 4. I looked at the bottom one. Funny. So x equals negative 4 was the equation of axis of symmetry for the third one. For the fourth one, the last one is x equals negative 1. Okay. Direction of opening, we said it's downwards. The vertex is located at negative 1, comma, negative 2. Okay, that's the x and y coordinates of the vertex. And because the problem opens downwards and we have a maximum point, the optimal value is a maximum value. And as we said over there, we said the optimal value is always k, so k is negative 2. So the answer would be negative 2 in this case. Okay, so I hope if you will be given these kind of questions on your upcoming quiz sometime soon, you will be able to identify correctly what the vertex is, what's the equation of axis symmetry, optimal value, direction of opening, and all these properties of the parabolas. I hope you will be able to figure out and answer those questions correctly. So I suggest you make a good copy of this chart. It's basically summary of, I should say, the whole chapter, the summary of the whole chapter. We had a separate lecture talking about A, if you recall. We had a separate lecture about K, and then we had a separate lecture on the decimals I showed you for H. The role of changing H was shown in that lecture, and this is basically wrapping up the whole thing, and the whole chapter 4 is like sort of summarized on this one single nice flow chart. Okay, so keep studying, and I hope everybody is safe and happy and healthy, and trying to study as much as you can. Okay, probably we're going to have maybe one more lecture in this chapter 4, and then we'll be done with chapter 4. Okay, thank you very much for your attention.